Hi guys, good afternoon. So in the last session, we were going with the OSPF and we had seen about OSPF authentication and we saw about the DR-BDR concept. Okay. Now today we'll see about OSPF virtual link concept. Now, what did you check about virtual link? What is a virtual link?
In OSPF, all the areas must connect with area 0. So when an area is not well tightly connect with area 0, we use the link to connect them. It uses area border routers to connect.
Mhm. Okay. That's it. So that means whenever you want to have communication between multiple areas, then you require what? First thing is ABR, right? And condition of ABR is what? That at least one of the interface of the router must be in the area 0. That is one condition. Okay. Then if you have multiple areas, so everywhere all the areas are like, it's not possible for all the areas to directly connect with the area 0. And this is where your virtual link concept comes in. Okay. So write the heading. OSPF virtual link. So consider, okay, before that, you must understand that a non-backbone area, that means area which is not area 0, can only advertise routes to backbone area. It cannot advertise routes to non-backbone area. Okay. So what it means? That a non-backbone area cannot inject routes into another non-backbone area. That means area 1 cannot inject routes into area 2. Then who can do it? Only backbone area can advertise routes to non-backbone area. Clear? That means if two non-backbone areas wants to communicate and exchange routes, they must be either physically or virtually connected to area 0. Or that is basically what backbone area. Either physically or virtually connected to area 0. Okay. So how we can virtually connect it? With the help of virtual link. Okay. So we can say to virtually connect a non-backbone area to a backbone area, we use the concept of virtual. Okay, we are going to use the concept of virtual. So if we talk about virtual link, okay, if we talk about virtual link, the virtual link is configured between the routers where backbone area is configured, that means ABR, and a router where multiple areas are configured. Okay, so you will say the virtual link is configured first of all two-way. That means two comments you have to give, one on the ABR, one on the multi-area router. Okay, that means from ABR to multi-area router. Okay, and from multi-area router to ABR. Yeah. Now, what is an ABR? An ABR is a router that has at least one of its interface configured in area, is configured in area. This is clear. One area how? What kind of range?
We don't have a rating, so then it may monitor it out at area one day. And could be area one rating. So you could router to area one day and you can do the move to
A router is not in an area. A router is not in an area. It is a link. That means the link between two routers. That is the part where you configure the area, not a router. Okay. So that concept is totally wrong. So if you want to configure virtual link, then you can use the following command. You can say router OSPF and process ID. Then you say area. Here you will give the transit area ID. Then you will say virtual link. Here router ID of the, that means whatever the endpoint is there. That means it is, if you are configuring on ABR, it will be multi-area router. If you are configuring on multi-area router, it will be ABR. Okay. So wherever this virtual link will land, that router ID it has to be. Okay. And if we talk about transit area, right? So this is the area that is present between your ABR and multi-area router. Okay. So transit area is the area present between ABR and multi-area router. Clear? And your transit area, it cannot be a stub area. Okay. Transit area should only be a normal area. That is the condition. Now we'll go and see the topology. Put it down. Then we go to now. Yep. Oh, okay. Only you are worried. Huh? Okay, so you can see here, this is the topology area 0, area 1, and area 2, right? So let's wipe all the notes. So from here, you can clearly understand what do I mean with the area. Area is the link between the routers, okay? Not a router. Okay, so let's write down the configuration. R1, 12.1, loopback is there. Right, all good. Hmm? Yes. What happened? Okay, I made it 11. Now fine. Okay, yes. Now, now, now fine. Okay. R2, Z 0 by 0, 12.2, 0 by 1, 23.2, 2.2, so 12.0 is in 0, and another one with that 23 will be in the area 1. All good. R3, 0 by 0, 34.3, 0 by 1, 23.3, so one is 23 and another one is 34. This is in area 1, 23 is in area 1, 34 is in area 2. Hmm? That is up to us. Anything I can just put it this side also. Totally fine. Okay. Like 2.2 we put in area 0, right? Same like that. R4, V 0 by 0, 34.4, then 34, area 2, all good. R1, R2, R3, R4. Copy. R2. R3. And R4. Okay. Now let's see. So we see here that these people will communicate, these people will communicate within themselves, and these people will communicate within themselves. So until this, until area 1, R1 will be able to communicate. R1 will have a route for 2.2 also, 23 also, and 3.3 also. But R1 will not have the information about 4.4 or 34. Let's see. If I take a look, do show IP route OSPF. I have 3.3. I have 3.3. I have 2.2, and I have 23. Do I have 34 or 4? No. And if I try to ping, right? If I say do ping and 3.3.3.3, I'll be able to ping. If I say do ping and 192.168.23.3, I'm able to ping. But if I'll try with 4.4 or 2034, I'll not be able to ping. Why? Because R4 will not be able to share the information. And even R3 will not share the area 2 information to area 1. That is not possible. Why not possible? Because this is a router where 2 areas are configured. This is not an ABR. This is a router where just 2 areas are configured. So you can say this is a multi-area router, but this is not area border router. Okay. Who is an ABR? R2 is an ABR. R2 is a ABR. Why? Because one of its interface is connected to area 0. What about R1? Is it ABR? ASBR. Is R1 ABR? Yes. Is R1 ABR? Answer is no. Why no? Because R1 has 2 interfaces configured, loopback and the gig 0/0. Both interfaces are in the same area only. So this is a router that is internal to the area 0. So this will be known as internal router. This will be known as what? Internal router. Is that clear? This is not ABR.
But if we connect one more area to router 1,
Then it will become ABR. For ABR, at least 2 areas should be there. And out of the 2 areas, one of the areas should be area 0. Clear? Okay. Now, right now, R1 is not having the routes for R4. And the routes that we see here, IA, what does it mean? These are inter-area routes. These are what? These are inter-area routes. That means the routes which are exchanged from one area to another area. Okay. All right. Now, let's go and configure here virtual link. So we'll configure here what? Virtual link. Okay. So virtual link here, it will be configured between R2 and R3. Between R2 and R3. So see how you'll configure the virtual link. Right now, if we check, do show IP interface brief, right? Not on R1, but on R2. We have two physical interfaces and one loopback interface, correct? Let's check on R3. Right, same thing. Okay, now let's start. On R2, I'll say router OSPF1 area. Then we have to give the transit area. The area that is present between the AVR and the multi-area router. Which area is present in between them? Area 1. So area 1. 1 will be the transit area. Then what we are trying to configure? Virtual link. Then I have to give the router ID. Router ID of the endpoint. Where I'm configuring? R2. So starting from R2, where my that virtual link will end? R3. It will end on R3. So I have to give the router ID of R3. Now, if I need to know the router ID of R3, so how I can know? I can say to show IP OSPF neighbor, and I can see the router ID is 3.3. So we will say area 1 virtual link and 3.3.3. As soon as I do this, on R3, you will start getting a log. On this router, you will start getting a log message that we are getting a virtual link request. Okay. OSPF process ID is 1 only, right? Yeah, then it's fine. This is clear. And if you check to debug the OSPF events, listen, see. Reason it's not showing here. Okay, let's configure here. It should show a log here that somebody is trying to create a virtual link. Now see here, router OSPF1, area 1, again the same, virtual link, and we are creating this with the 2.2. Okay, and the virtual link should come up. Came up. You see a logical interface created. OSPF virtual link 0. From where to where? It changed the state from loading to full. Okay, same thing here. And now if we check, earlier I was having how many neighbors? 2 neighbors only. Now if I check, I have 3 neighbors. 1 extra neighbors through which interface? Virtual link 0. Clear? And now you will be able to see. To show IP route was clear. You can see 4 also. You can see 34 also. Yeah. Looping 4.4.4.4. we have the communication. This is how your virtual link concept works. Clear? Online people clear?
Yes, sir.
Both sides you have to configure. One side will not work. If you try. Virtual link is down. You'll see that virtual link request will be arriving here. See here. This is sending and this is receiving. Protocol number 89. So those packets are coming here. From 23.2, you can see packets are coming. Clear? So this is clear. Okay, next heading. So virtual link is clear. Then you can have nested virtual link also. Now, what do I mean with the nested virtual link? Right now, I have a link, between R2 and R3. Let's say after R4, there is one more area 3. So again, area 3 will not communicate. So then you will have to create between R3 and R4. It's not like you will create from R2 to R4. No, you will create between R3 and R4. A virtual link you will configure between R3 and R4. Same way, again, next one, like that. So when you have multiple virtual links, okay, so that situation is known as nested virtual links. Yes. Okay. Okay, then next heading. OSPF, LSA types. So how many types of LSA? Yesterday you were telling 7. What happened? Okay, because the LSA 8 to 11, they are out of the scope of CCNP. So you say, what is an LSA? Now see, in the books, you will see they have very lengthy description about these things. Okay, very lengthy description about the LSAs. Okay, like if you see one of the book. In the CCNP book, if you will see, three, and now this is the old book. Okay, but right now we have to go until 7 only. Okay. Now, according to this, if you will see, right, let's say These are the ones we require as of now. Okay. So we know that every router that connects to a given OSPF area that should learn the exact same topology data. That means every router on the OSPF, they should have the same topology or same database. So each router is going to store the data, which is composed of different link state advertisements or LSAs, where it will store LSDB. And in this LSDB, the router will apply what? SPF to determine the best route. Correct? So this LSA is what? This LSA is the having the information about the topology, having the information about the topology. Okay. So here we can say that there are total how many types of LSAs? 11. There are 11 types of LSA, but LSA 8 to 11 are out of scope for CCNP. Hmm. Because these are used as a generic LSAs only. Okay, like they want to extend the features. Both of them are used for the same thing. Okay, that is good. Now, total 11 LSAs are there, but out of that, 8 to 11 are out of the scope for CCNP. And your LSA type 6, you will see that we don't have type 6 also. This one you will not study. Why? Because you see here, not supported by Cisco IOS. This is not supported by Cisco IOS. So the LSA type 6 is known as MOSPF, and this is not supported. So that means overall, how many LSAs you're left with? 6. Okay. Now, if you see LSA type 1, the router LSA, the router LSA. So first of all, this LSA is created by all the routers in an area. Every single router in an area will create what? Type 1 LSA. Okay. Whatever the number of routers are there in the area, they will create what? Type 1 LSA. And in what area, in how much part of the area, or in how much part of the topology it will flood? So it will remain within an area only. That means according to a topology right now, how many networks we configured in the, like how many routers are configured in area 0? R1 and R2. Take a look. Okay, in our topology, I have R3, R4 also. In my topology, I have R3 and R4 also. So let's see. Go on R1. Do show IP was clear. Database. Now you see here. This is has generated what? Type 1 LSA, type 1 LSA, and type 1 LSA. Do you see? So why I'm able to have 3.3 also? Because of, not because of virtual link, because it is directly connected to area 0. Okay, because we have an ABR in between. That's why. Otherwise, you see R4. R4 is not coming here in this area. See here. R4 information is not there. Is that clear? And if you go on R4, do show IP OSPF. So IP OSPF database. Here only we have 3 and 4 because only 3 and 4 are configured in the area 2. Is that clear? Yes or no? So only your, not only, every router in the area will generate type 1 LSA. And this LSA will flood within an area only. This cannot go out of a area. Clear? So each router creates its own type 1 LSA to represent itself for each area to which it connects. And the LSDB for one area contains one type 1 LSA per router per area. For one router, one area, there will be only one LSA, listing the router ID and all interface IP address on that router that are in the area. So that means in the type 1 LSA, we have the IP address, whatever the IP address is configured on that router, that information will be there. Okay. Then LSA type 2, it is generated by only DR. Even your BDR will not generate it, right? Even your BDR will not generate this LSA. So this will be generated only by the DR. Okay. So if we take a look, let's say R3, R4, who will become the DR? R4, either higher priority or higher IP address or router ID, sorry. So higher router ID is with R4. So when you take a look at type 2 LSA, if you see the type 2 LSA, that is network link state. So we have only information about R4. Clear? Okay. And this LSA will also flood within an area only. Okay. You can see that I might be having a different DR between 2 and 3. 3 is the DR, but that information, do I have it here? No. This is only specific for area. This is clear? Okay. Then network summary LSA. So this is created by the ABR. This is created by the ABR to represent subnets listed in one area's type 1 and type 2 LSAs when being advertised into another area. So that means whenever ABR has to advertise the routes from like type 1 and type 2 information from one area to another area, it will create what? Type 3 LSA. So let's say in the area 0, 3, 2, exactly same time. Right, John? Wait for it. So let's say in area 0, I might be having some type 1, type 2 LSS. In area 1, I might be having some type 1, type 2 LSS. So these type 1, type 2 LSS, when we want to, like when this ABR has to flood it inside the area 2. So that time it will create what? Summary LSA. Okay. So you see here, whatever the information from area 1, area 2 is there, that information is flooded. And who is the advertising router here? Advertising router is the ABR. We just created virtual link, right? So that means now this guy is also a ABR because it is virtually connected to area 0 now. So that's why advertising router is R3. So that means these routes coming to R4 with the help of type 3 LSA. Understood? Okay. What confusion? Whatever the routes are there from area 1 and area 0 and area 1, they will be advertised to area 2 by the R3 with the help of summary LSA, type 3 LSA. The type 1 and type 2, they are converted into type 3 and advertised here. Clear? And that is the reason you can see in the type 3, I'm having all the information. Understood? Why? Why not R3? We created a virtual link, right? And what is the condition for ABR? That the particular router, either it has to be physically or virtually connected to area 0. So this guy is connected, right? Virtually. Okay. So somehow this guy needs to have at least one of its interface in the area 0. So it has OSPF virtual link interface in the area 0. Yeah. Okay. Then ASBR summary LSA. Now this ASBR summary LSA, this is when you have more than one protocol. So it is same like a type 3 LSA only, but it will advertise a host route, and this is used to reach the ASBR. That means basically this is advertising a route for the ASBR. That means whenever you want to go in a different protocol. So that time type 4 LSA will be there. Okay. So it's same like type 3, but it will advertise a host route that is used to reach the ASBR. Clear? Then type 5. So again, AS external, this is created by the ASBR for external routes injected into the OSPF whenever you do the redistribution. So whenever you inject external routes into OSPF, those routes will be converted into type 5 LSA. Those routes will be converted into type 5 LSA. And later on, you will see when we will start filtering, type 3 LSAs and type 5 LSAs. You'll understand. This is clear. Then type 6, not supported. Type 7, NSSA, external. Same like, same like type 5 only, created by the ASBR. But in the not so stub area, your type 5 LSA is blocked. If type 5 is blocked, that means other routes will not come into the area. They will come, but with the help of type 7 LSA. They will be injected into OSPF with the help of type 7 LSA. So type 3 and type 4 are similar. Type 5 and type 7 are similar. So you can say that this is for multiple areas. This is for multiple protocols. Okay. And then type 5. Type 5 is used to inject the routes. That means any protocol, let's say EIGRP, I will redistribute into OSPF. So the EIGRP routes will be converted into type 5 LSA. But what if in my area type 5 LSA is blocked? In my area, if type 5 LSA is blocked, that means EIGRP routes will not come. So what my ASPR will do, instead of type 5, it will generate type 7. When the type 5 is blocked, in that case, it will generate type 7 in case of not so stubby area. So that is depending on the area. This is clear. So these are the 7 types of LSAs we have. Clear? Online people clear? No, according to area. The next part is about area types only, so that you can understand. Okay. Now let's go with the OSPF area types. Next study. OSPF area types. Okay. So how many types of area is there in OSPF? Hmm? Sorry. Right. What are they? Hmm. And backbone, non-backbone. Hmm? Standard area. Then backbone. Stub area. Not so stubby area. So standard areas, your regular areas. Okay, so those things we will not discuss, but remaining 4 we will discuss. Stub, total stub, NSSA, and total NSSA. Okay. Okay, overall, you can see four areas will be there. Four type of stub areas will be there. Okay. So we have total four types. Out of them, two will have total and two will not have this thing. So the difference between the word total and those with that are not having is what? Whether type 3 LSAs are flooded into the area or not. So there are certain rules, right? For all types of stubby areas, what will happen? That they will filter type 5 LSAs. Okay. And for total stub and total NSSA, they will also filter type 3. That means stub area, okay, and not so stub area. Both will filter type 5. Stub area and not so stub area, they will filter type 5 LSA. But total stub and total NSSA, they will filter type 3 as well as type 5. This is clear. So you can see for stubby areas and NSSA areas, those without the word totally in the name, the ABR do not filter type 3 LSA. They will advertise the type 3 LSA as normal. Now this might be a bit confusing. So let me note it down. Okay. See here. OSPF stub areas are of four types. Number one, stub, total stub, NSSA. NSSA means not so stub area. And total NSSA. Okay. So the stub areas or all of these types of areas, so they will not allow type 5 LSS. They filter type 5 LSS. Is that clear? They do not allow type 5 LSS. So note it down. The stub areas do not allow type 5 LSS. They will not allow type 5 LSS. Okay. And the stub areas that have the total word, they do not allow type 3 and type 5. Okay. Type 3 and type 5 LSA. This is clear. So now if the LSAs are flooding less, that means this will have what? Smaller OSPF database, which results in small routing table, less memory consumption, less CPU overhead, benefit. Okay. This reduces the number of LSAs, which results in smaller OSPF database, and this results in less memory and CPU overhead, and helps in faster SPF calculations. But remember, area 0, you cannot configure it as a stub area. Area 0, that is backbone area, cannot be configured as stub area. Yes. Now, first of all, stub area. Okay. So number one, it blocks Wi-Fi LSA, and here ASBR is not allowed. Okay. In the stub area, there cannot be any ASBR. And what it will do? It will automatically originate a default route for reachability. For reachability, it will automatically originate a default route. If you want to configure stuff, so you'll say router OSPF, process ID, and area ID stuff. This is clear. Okay. So first, let's note down all the areas, then quickly we will see the practical for all of them. This is stub. Now let's talk about total stub. Total stub. Okay. It filters or it blocks type P as well as type by LSA. Okay. Here ASBR is allowed. Okay, and since type 5 is filtered, so the outside routes, if they will come in, they will come as a type 7. Yeah. So here what will happen? The default route will not automatically be originated. We have to manually originate, or we have to manually define it. Okay. So we have to manually originate a default route for reachability using the command default information origin. Yes. And because type 5 LSA is blocked, ASBR is going to generate what? Type 7 LSA. As the type 5 LSA is blocked, the ASBR will generate type 7 LSA. This is clear. So here two different configurations will be there, one for other routers, one for the ASBR. So on other routers, how you will configure it, and on ASBR, how you will configure it. Okay. So on other routers, you will see router OSPF process ID, and you will say area ID. And this time we don't want any summary LSA, so you will say no summary. Okay, stub and no summary. And on the ASBR, you will say only area ID stub. Router OSPF process ID, and you will say area ID stub. Yes, this will be the configuration. Yes. Now between total stub and not so stub, what is the difference? ASBR is allowed. Here ASBR is not allowed. There ASBR will, sorry, here ASBR is allowed. There also here ASBR will be allowed, but there only type I will be filtered. Okay, that is not so stub. Type 3 will be allowed there. Third one, NSSC. So in NSSC, what will happen? It blocks type I LSA. Here ASBR is allowed. Okay. Here also we have to manually originate a default route for reachability. Okay. Using the command, same command. Default information origin. Okay. And since type I LSA is filtered, ASBR will generate type 7. Okay. Configuration. So on other routers. Router OSPF process ID and area ID, and you also unnecessary. Yes. Then on HBR, you will say router OSPF process ID, area ID, unnecessary, and this one, let me verify this. OSPF 1. So here it will be here only default information originate. Okay, and here this thing will come as a comment. And there will be a space here. This is total stop. Wait. Just remove this point. Yeah, this one. This is not there. This will be in the total analysis. Here, automatically. Side switch. And also remove this point. This one. Yeah. Here the things will be automatic. Right here.
type will be converted to type 7 automatically. Or
Default route is there, right? Here default route is there. Okay. Now total NSSA. So here it filters right and by LSA. And the ESBR is allowed here. Okay. And the default route is automatically on speed. For picture. Okay. 5, 3, 5, 5. Router was the process ID. Okay. And you will say area, area ID, NSSF, and also this time we don't want any summary. And on all the other routers, area ID, NSSF. Yes. Okay. One small change. It will be ABR, not ASBR. Here we have sent right ASBR. So instead of ASBR, we just make it ABR. Just remove the S. Okay. Not ASBR, but ABR. See here. The ABR will always filter. So ABR is going to filter all these things, not ASBR. Okay. Make it ABR. Now everything is okay. Now let's go to the lab. Quickly we will see all these things. So what I'm going to do on R1, let's say this is the network, right? 1.1.1.1. So instead of advertising it in the OSPF, I will advertise it or I will redistribute it. So that we'll get a ASBR also. Okay. Configure terminal. We show run 5 section OSPF. Go to OSPF1. And I'll say redistribute connected. Then now what happened? R1 became the ASBR. Yeah. Okay. Now let's see here on R3. Do show. So we can see here all the 7 types of LSA. Type 5 LSA is also there. Summary ASBR link state is also there. Summary network link state, router link state, right? So we have all these things. See here, summary ASBR link state, then network link state, router link state. Then again, summary network link state, and router. So that means for area 0 also we have, for area 1 also we have, and for area 2 also we have, right? This is type 5. Then see here, according to the name, if you check, not this one, AS external, ASBR summary, okay? So up till 5, type 5 LSS we are getting, you can see here. Type 1, type 2, type 3, type 4, type 5, right? And since type 5 is coming right now, so there is no type 7, correct? Now let's go on R2 and R3 and let's configure the area as stub. So this is area 1, right? I'll configure area 1 as stub on R2 and R3. See here. Enable, configure terminal, router, OSPF1, area 1, stub. First of all, we will configure stub only. Cannot be stub as it contains a virtual link. So let's remove that virtual link also. No area 1 virtual link. Virtual link 3.3.3.3. Okay, now there is no virtual link, right? So I'll say area 1 stub, and on R3 router OSPF1, no area 1 virtual link 2.2.2.2, area 1 stub. This is first of stub configuration. Done. So earlier we were having up to type 5. So stub does what? Filters type 5 filtering. So that means type 5 LSA will not be there now. Earlier I was having type 5 AS external link state. Now do show IT was here database. You see, wait for it. This is for area 2. It will take some time to clean up. Virtual link has been removed. Wait for it. Still showing. Type 1, type 2, type 3 is there, then type 1, type 2. Type 1 is there, type 2 is there, type 5 is there, type 3 is not there. And we just configured stub only, right? We didn't run. It's actually OSPF. Outer OSPF 1, area 1, stub. That is fine. We don't show our IP route. So we can see here that the default route has been automatically originated. That part is fine. Okay. But still, why it is showing type 5? Let me check on the ABR. It will show IP address. Here it's also showing. Do show run. It's actually OSPF. Area ID stub. This is fine. 2.2.23 is there. Yep. The default route originated, that is fine. This is being done. But the thing is, that is still it is showing type 5. But it is not showing type 3 for area 2. For area 1, it is showing. To show IP OSPF database, do we have show IP? External, internal network router summary. Include area 1. Type 1, type 2, type 3, that's okay. This is showing type 5. Advertising router is 1.1. Okay, let it be. Let's try the next one first. Next one is, okay, after stub we have total stub. So in the total stub on the ABR, the configuration is okay. On the ASBR, we have to say no summary. No, sorry, on the other routers, we have to say no summary. So let's see. If I go on R3, okay, wait a minute. On area 2, I mean R4 also, let me configure stub once. Might be possible due to R4, the some that is coming. On R3, if I go and shut down the interface Z0/0, interface is 0/0. Sorry. Yeah. That means this side I do not want to form any neighborship as of now, so that it will not conflict with our configuration between 0 and 1. Now let's check the database. So IP database. So let us see. Area 2 routes are there, right? Wait for it. How come area 2 is there? Hmm? Hmm. Okay. Do clear IP OSPF process. Yes. Only one neighbor it's showing, and neighborship came up again. It's the run section OSPF. It will show IP OSPF database. Now you can see type I is not coming. That was because of the old configuration only. Okay. So stub area is filtering type 5 LSA, but still type 3 is there. Type 3 is there. So what we can do? We can go to router OSPF1 and I can say area 1 stub, but I also don't want any summary. So if I say no summary, automatically the summary LSA will also be filtered. Okay. So now if I check, do show IP OSPF database. So let's say do clear IP OSPF process. Yes. So you'll have to clear the process, otherwise it will not reflect immediately. Wait again. We will show run. We have stub no summary. That is fine. Okay, that is on the wrong router. We have to configure it on the ABR. Here you have to configure it. Start with no summary because ABR will block it, not this normal router. We will show IP OSPF database. Right now it is there. We go clear IP OSPF process. Yes. Do show IP OSPF database. So you see, we have only the default route information. We don't have the type 3 LSA. Okay. Do show IP OSPF, IP route OSPF. So this is the default route that is also. This is clear. Okay. The third one was about NSSA, right? So here we have to manually originate the default route first thing. And here we will see type 7 LSA instead of type 5. So type 1, type 2, type 3, and type 7 LSA we will see here. Okay. So let's go and configure it. So on other routers, I'll say, first of all, no area 1 stub. And I'll say area 1 NSSA. Right? This is done. And on this route, I'll say area 1 NSSA. And if you want to originate the default route, you will say default information originate. Okay. No area 1 stub. Done. Now let's verify here. To show IP OSPF database. You see, this time we see what? Type 7. Okay. We see a type 7 LSSA. I mean type 7 LSA, and we have a type 3 LSA. Here type 5 is not there because type 5 is blocked. Then if we will say what, it will, if we are going to say here, like no summary, then it will not advertise the summary also. Okay. So here we will say NSSA. This is R3, right? And wait a minute. Yeah. Yes. So see, in here we will keep it as it is, and here we are originating default information. Instead of that, I will say no summary. Then now summary LSA will also not be originated. This is already unnecessary. So clear IP OSPF process. Yes. We show IP OSPF database. So you can see we only see, first of all, type 5 is blocked. So type 7 is there. And in the type 3, we just have the default route. That's it. Do show IP OSPF database. Not this. Do show IP route OSPF. Only the default route. This is clear. So this is how your area stub area type system. So your stub and NSSA, they filter type 5, while your total stub and total NSSA, they filter type 3 as well as type 5. Clear? Online people, any doubts?
Oh, sir.
No, same.
All right. Okay, guys, then this is it for the day. Then for tomorrow, we are left with summarization and filtering is left. Okay. So you will check about summarization and filtering, and then we will start with the BGP tomorrow. Okay. All right. Okay, guys, then this is it for the day. I'll see you guys tomorrow. Have a good day.